Hello and welcome back after the break. Our next topic that we're going to discuss is drainage basins. Now, if you look at the definition of a drainage basin, it's an area drained by its river and its tributaries. This form catchment areas of a river system. Now, let's just quickly decipher it because there's quite a few terms that's quite important to be able to understand this. Now, all rivers develop from a source. It might be springs, it might be a high-lying area, but it develops where the water originates from. And as the river flows, usually down to your ocean areas, where the river flows into the ocean is known as the mouth. Now, the course of the river is known as the river channel. Now, very importantly over here, other rivers that joins the main rivers is known as tributaries, as you can see. So let's say, for instance, our source river over there is the example of the Gr12 river that flows down in the southeastern section of South Africa, down in KwaZulu-Natal. So the source is all the way up in the Drakensberg Mountains, and the mouth is in a small town called Mandini, where the river is almost a kilometer wide. The source is just a small, basically small amount of water coming from the mountain areas. And where the mouth is a huge volume of water eventually flows into the ocean. Now, other rivers that joins the Gr12 river is known as tributary rivers. That can be the Umkomaas River, Umsintoti River. Now, the area, the high-lying area that separates one tributary, let's say, for instance, that's one tributary and there's another tributary, is known as a interfluve. Now, what is the interfluve? It's a high-lying area between the two tributaries. It's a high-lying area between two rivers joining the main river. Now, confluence, if you look at that term over there, is where two rivers join. There's one river joining and there's another river joining. And very importantly, lastly, is a watershed. The watershed separates one drainage basin from another. For instance, this can be the Gr12 drainage basin. On this side can be the Vaal River or the Orange River Basin. So there is another source with its own tributaries flowing into it. So what does the watershed do? This watershed separates drainage basins from one another. Now, drainage density, what we've learned before the break, is surface runoff and groundwater runoff. If a drainage basin's got a high density, it looks as follows. This is high density over here. And this drainage basin got a low density. Now, if you look at high density and low density, the difference is actually the visible water is the surface runoff. Now, as you can see, if you look at this high density area over there, we can say this is the source of the river and this is the mouth of the river. What do we call these? These are known as tributaries. What separates the tributaries from one another? What do we call this area over there? Interfluve. It's a high-lying area. But as you can see, drainage basin 2 has got a high density. It's got many tributaries. 1, 2, quite a few, where drainage basin 1 has only got 2. So there's not much water with the low density as in a high density. So if a drainage basin's got a high density, it means it's got more water. more surface runoff, and even more infiltration, depending on the following factors. And we already discussed them, and they're very similar to the ones that we discussed influencing direct and indirect runoff. The amount of rainfall. Let's assume Drainage Basin 2 is in KwaZulu-Natal. And let's assume Drainage Basin 1 is in Northern Cape Province. More rainfall in KwaZulu-Natal than in Northern Cape Province. More tributaries will be visible, more water. There will be more surface runoff and even more infiltration. Now, rainfall not always plays the main factor about high density and low density. Relief also plays a vital role. Now, relief refers to the steepness of the slopes. Now, the high density one, number 2, do you think it's a steep gradient or a gentle gradient? And do you think the low density is going to be a steep gradient or a low, steep or gentle gradient? Now, very simple matrix. If you look at the situation scenario over there, if it's going to be a steep gradient, will the water be able to infiltrate? No. The discharge of the river is going to be much quicker. We looked at it at the hydrograph. So when it's a steep gradient, we're going to experience a high density. The water won't have time to infiltrate. So what we're going to say is promote surface runoff. Now, when the gradient is gentle, will the water have time to infiltrate? Yes. So that means there's going to be less surface runoff. So if you look at Drainage Basin 1, the chances that the gradient is gentle and the chances that the gradient is steep with the high density is more likely. Then the permeability of rock, we already discussed it. We got permeable, impermeable. What did we say? The permeable allows the water to infiltrate. Impermeable do not allow the water to infiltrate. So if we look at the densities over here, first of all, the low density. It's only a couple of tributaries. What do you think happens over with the water? It's definitely got permeable rock. It allows the water to infiltrate. And if you look at the high density drainage basin over there, what type of underlying rock do you think is situated over there? Definitely impermeable rock. It doesn't allow the water to infiltrate, so the river rather flows in its river channels. The water flows in the river channels. And last but not least is the vegetation cover. Okay, vegetation cover, let's say it's an area with lots of vegetation, it's going to promote a low density drainage basin because the water is rather going to infiltrate. If there's less vegetation cover, as you can see over there, water, the vegetation, what does it do? It promotes infiltration. And if there's less vegetation cover, the chances that it's going to be a high density drainage basin is more likely. So the four factors are very similar to the indirect runoff and direct runoff. Surface runoff, groundwater runoff. Now, very importantly, Gr12, is your drainage patterns. Now, all that you need to do over here is to determine and to describe the pattern of the river. Now, keep in mind, this question can pop up in your mapwork paper as well as in your theory paper. So what you need to be able to do is you need to be able to identify the pattern of this drainage basin, and you need to go and look at the characteristics why this pattern developed. Now, there's three patterns that you need to get yourself familiar with, and we gave it to you in table form. Now, your first one is your dendritic pattern. It's your most common pattern. It's very easy to be able to recognize it because it resembles the branches of a tree. But I want you to focus on the next characteristic. First of all, you need to identify the drainage pattern. It's very easy. It looks like the branches of a tree. It's tributaries joining at acute angles from all different angles. But very importantly, the reason why it joins like this is the following. The underlying rock is homogeneous. What does it mean? The underlying rock is exactly the same. It means it's got the same resistance. It means the underlying rock underneath that drainage basin is the same. It means there's the same amount of infiltration taking place. It's not like it's a mixture of rocks that's permeable or that's impermeable. It's only permeable rock or only impermeable rock. So to remember the characteristics, remember this. To identify it, look at the shape of it. It's like a tree shaped, the branches of a tree. Very importantly, it's got the same type of underlying rock, meaning it's got the same type of resistance. There's not a rock that allows infiltration and more erosion than other rock. Our next pattern is trellis. Now it's quite easy to identify it because it's tributaries joining at 90-degree angles. Now it's basically parallel streams, as you can see, but the tributaries joins at 90-degree angles. Now the difference over here, if you look at the characteristics, the reason why it forms over here, the areas in between them are more resistant to erosion and weathering, whereas the stream channels are. Very importantly over here, it occurs where the surface rock, there's different types of resistance. There's strong and weak rock. So the weak rock might erode much easier. For instance, sedimentary rock where folding took place. Our last drainage pattern is radial patterns. Now it's very easy to identify because it's outflowing. As you can see from a high-lying area. As you can see over here, streams flow outwards from one higher central point. For instance, domes or volcanoes. Now, as you can see, very importantly over there, how you're going to identify that on a topographical map, you're going to look at the contour lines. The contour lines is going to decrease outwards. Now, these patterns are very important. You're definitely going to get one of each or one of them during your theory paper and your MAPU paper. Once again, Gr12, identify the pattern and know the reason why the formation of this pattern. So go and look at it, how do you describe it, and very important, the type of underlying rock. Now, if we could just quickly look at the summary of this lesson, we look at the different processes, fluvial processes, how water runs. Direct runoff, indirect runoff, surface runoff, groundwater runoff. Why does it happen? Because some areas receive more rainfall, some less. Some areas are covered with more vegetation, some areas is covered with less vegetation, and the steepness of slopes. We look at the water cycle. Now, very importantly, it's a closed cycle. All the conditions that we looked at every single point, where evaporation takes place, eventually where condensation takes place, precipitation takes place, and how this water eventually flows back into our oceans. We looked at our different types of rivers. Up to now, you only know about permanent perennial rivers and non-perennial rivers, but today you've learned about permanent rivers, episodic rivers, and periodic rivers. Very importantly, remember the water table, if the water table will be visible or not. And we look at the river discharge as the amount of water that flows in the river. To determine that, we use a very specialized graph, a hydrograph. It shows us information in the bar graph and the line graph. The bar graph represents the amount of precipitation, the rainfall, and the line graph, the time that the discharge are taking place. Then we also look at drainage basins. It's a river with its tributaries draining an area. Very importantly, just the basics, the source of the river to the mouth of the river. I just want to draw it because it's quite important over there. There's your source, there's your mouth, The other rivers joining is known as your tributaries. The high-lying areas that separates one tributary from another is known as your interfluve. What separates one drainage basin from another is a high-lying area known as a watershed. And then we look at that drainage density. That's the amount of water that's in this drainage basin. If there's a lot of tributaries, like this one over there, it means it receives more rainfall, less vegetation cover, steeper slope, and probably because of impermeable rock. When the drainage basin's only got a few tributaries, we say it's a low density. Simple reason for it, because the rainfall is quite less over there. Reason might be because there's a lot of vegetation cover, it's a gentle slope, and it might be impermeable rock. It allows water to infiltrate. And lastly, we looked at our different patterns. Now remember, you need to be able to identify these patterns. They are dendritic, tree-shaped. They are trellis, parallel with one another, join at 90-degree angles. And then we've got a radial pattern that flows from a high-lying area to a low-lying area. Now know why they form. Dendritic because of the same underlying rock. If you look at your trellis patterns, not the same type of underlying rock. One rock is more prone to erosion and weathering than the other one, and radial pattern is from a high-lying area to a low-lying area. Thank you for watching. See you next time.